Understanding logarithms. Today we are going to talk about what logarithms are and develop an understanding of those numbers. A fairly common way of reading about logarithms is people just memorize the formula and use it in different situations, and that is how they know about logarithms. But that's not what we are going to do today. What we are going to do today is we are going to understand what it means, the theory behind this, the concepts behind this, so that when you see the logarithms, you'll naturally understand, and the formulas will come naturally to you that this is what it means. This is why this is the formula. You wouldn't have to memorize those. So we'll try to understand the science behind those numbers. What do those numbers mean? So before we start, let's try to define what logarithms are. In a vague way, logarithms are a different way of writing exponents. So a raised to the power x is equal to b. What this means is a exponent x, if its value is b, then logarithm of b to the base a is equal to x. What have we done here? All we have done is we have shuffled those numbers. A became here, x came here, and b came here. We haven't changed anything. We have just, whatever this was, we have rewritten it in a different format. This is what logarithms are. Rewriting the exponents in a different format. That's it. But let's take an example that will clarify things more. We'll get to this formula, but we don't have to remember this. Let's see if we can come to this formula. Let's take an example. 2 raised to the power 4 is equal to 16. Let's think. Let's spend some more time here. What does this mean? This means 2 multiplied by 2 multiplied by 2 multiplied by 2 becomes 16. In a way, what you have done is you have taken 2 and multiplied it with itself 4 times. 2 into 2 into 2 into 2, and the result that you get is 16. We haven't talked about logarithms so far. All this is about exponents. Make sense? Let's think more. In a way, what is happening is so this 2 became 4, this 4 became 8, and this 8 became 16. So you multiply it by 2, you got 4. You multiply it by 2, you got 8. You multiply it by 2, you got 16. And you multiply it by 2, you get 2. Initially, this is how it is. What this means is, in a way, if you had a basket, to start with, then if you multiply it by 2, you get 2 baskets. Then you get 4 baskets, and 8 and 16 and so forth. What this means is, in a way, what you have is a doubling machine. First time you doubled it, you got 2 times whatever you had. Then you doubled it, you got whatever you had became 4 times. Then you doubled it again, it became 8 times. Then you doubled it again, it became 16 times. So what you have is a doubling machine. Basically, every time you double it, this number, this tells you how many times you doubled it. Here we doubled it 4 times. This number becomes, whatever you had is becoming bigger and bigger and bigger. So if you had 1 basket, it became 2 baskets. You doubled it once. You double it again, these 2 baskets become 4 baskets. If you double it again, these 4 baskets will become 8 baskets. If you double it again, this 8 will become 16. If you double it again, this will become 32. If you do it again, this is becoming 64. So in a way, what you have is a doubling machine. right? These exponents are nothing but a doubling machine, and this is a doubling machine. This is time. How many times were you doubling it? And this is, what is the result? The final outcome. So, in a way, what it means is, if you are doubling and you double it 4 times, then whatever you had becomes 16 times. Let's take another example. 2 raised to the power 5 is equal to 32. If you are doubling and you double 5 times, 2, 4, 8, 16, 32, then whatever you have becomes 32 times. Let's take a simpler example. 2 raised to the power 1 is equal to 2. If you are doubling and you double it only once, then whatever you had will become twice. I had 1 basket, I double it once, it becomes 2 baskets. Another example. 2 raised to the power 0 is equal to, I am doubling, I had 1 basket, but I haven't doubled it, right? 0. I haven't doubled it any time. The time hasn't changed at all. So what would be my net result? 1. Why 1? 100%. Basically what it means is, you haven't grown at all. If you had 1 basket, it remains 1 basket. Nothing changes. Another example. 2 raised to the power minus 1 is equal to 1 by 2. What does this mean? This means, if your final size is half of what you are, then how many times did you double? This means you didn't go forward in time. Otherwise your size would have grown. You went backwards in time. So if time was growing like this, you went here 1 units of time and your size became 1 by 2. This is why 2 raised to minus 1 becomes 1 by 2. Does this make sense? In a way, what we have understood is exponents. So this is like your doubling machine, what you are doubling. This is your doubling machine. This is what you are doubling. This is how many times you are doubling, and this is the result. Let's take another example. Five cube is 125. What does this mean? This time you are not doubling. What we are doing is, whatever we had, we are making it 5 times its size. So in a way, our growth factor is this 5. 3 is how many times we do it, time, and 125 is the result. So if you had a basket, 1 basket to start with, after 1 unit of time passes, because our growth factor is 5, what would be the size? 5 baskets. After 2 units of time, this will become 5 into 5 equal to 25 baskets. After 3 units of time, this becomes 5 times again. 25 becomes into 5 times. 25 into 5 is 125 baskets. So now you get a sense of what is happening. This is like a growth factor. This is like how many times you did it, the time factor, and this is the final result. Make sense? Okay. Let's write this in a different way now, in a logarithmic way. So what we do is, we say log of 125 to the base 5 is equal to 3, or log base 5 of 125 is 3. Okay, what does this mean? Let's apply these concepts again. So this 5 is your growth factor, this is time, and this was result. So what it means is, with this logarithm, by the way, we don't write complete logarithms because it's long. We just write log, which is shorter format. So if your growth factor is 5, if you are becoming 5 times every unit of time passes, and your final result is 125, that is, you are 125 times the original size, how much time would it take? This is 3. This is what it means, logarithms. Make sense? Let's take another example. Log base 2 32 is equal to 5. In a doubling machine, where whatever you had, if it is becoming double of every time, every unit of time passes, and finally you were 32 times the original size, then how much time would have passed? 5. 2 raised to the power 5 is equal to 32. In a way, what has happened is, all I have done is, I have taken these numbers and written it in a different format. That is what logarithms are, which I said initially. Logarithms are a different way of writing exponents. This 2 became here, subscript, this 5 went here, and this 32 came here. We have just shuffled these numbers and written it in different formats. So whatever this meant, it has the same meaning, just in a different format. This says, if you are doubling and you double 5 times, you become 32. This says, if you are doubling and your final size is 32, you would need 5 times to get to this. That's it. This is what logarithms are. Now let's try to understand the formulas. Let's see what that means. Log of a into b is equal to log of a plus log of b. What does this mean? So whatever your growth factor was, if a into b is your final size, let's take this as an example. Let's take an example of what we were doing earlier. 2 raised to 5 is equal to 32. Log base 2 32 is equal to log base 2 4 into 8 is equal to log base 2 4 plus log base 2 8. We had a doubling machine and our final size is 32, which could also be written as, it first became 4 times its size, and then it became 8 times its size. So in the first 2 units of time, 2t, whatever we had became twice its size. So this is 2t, which is log 4 to the base 2, and then in another, if it is going to become 8 times its size, how much time is it going to take further? 2, 4, 8, 3 times, which is 2 plus 3 is equal to 5. So log 32 to base 2 is 5. which we are also getting by log 4 base 2 plus log 8 base 2. So what's happening is, whatever we were multiplying here, in logarithms we sum those numbers. It's similar to a raised to the power b, a raised to the power c is equal to a raised to the power b plus c. It's the same thing. Here we were multiplying and then indices get added. This is what is happening. You are multiplying and then they get added in logarithms. Okay. Let's take another example of multiplication of powers. We saw the multiplications already. Log of a raised to the power n is equal to n log a. What does this mean? This is our final result, right? If our final result is a raised to the power n, what this means is it is a into a into a into a n times. What this also means is you took time t plus time t plus time t plus time t, so on, n times, right? Because n times you won't multiply, you will sum. That is why this becomes n times log a also, right? Okay. So this is what logarithms are. In a way, we understood what logarithms are. What we learnt is, if a raised to the power x is equal to b, then logarithm to base a of b is equal to x. It's just a different way of writing exponents.